In this lesson, we're going to go over solving a system of equations in two variables by graphing, substitution, and elimination, and then we're also going to solve a system of equations in three variables. When you have a system of two equations, you have three things that can happen. First, the two graphs intersect at one point, or you have parallel lines, or you have that the two equations become the same line. If you have two lines that intersect at one point, then the algebraic solution is going to be that point where they intersect. If you have parallel lines, then the algebraic solution is going to be no solution, and then if they end up being the same line, you would say infinitely many solutions. This example says solve the system of equations by graphing. So the first thing we're going to do is take both of these equations and rewrite them in the form of y equals mx plus b so that we can graph them. For the first equation, we want to get the y by itself, so we're going to add 3x. Then we're going to divide out the 3, and when you divide the whole equation by 3, you get y equals x plus 1. To graph this line, we're going to start with the y-intercept, and then the slope is technically 1 over 1. So from here, we're going to go rise 1 and run to the right 1. And here's our line. Next, we're going to take the second equation and isolate the y. So we're going to subtract this x over, and now divide the whole equation by -2. So -1 divided by -2 is going to be 1/2, and -4 divided by -2 is +2. For this equation, we have our y-intercept as +2, so I put a dot right there. And then now we're going to use the slope up 1, run 2. The point where the two graphs intersect is right 2, up 3. So our solution for the system is the point 2, 3. For this next system, we have our first equation is y equals -x plus 1, so it's already in slope-intercept form. So we plot up 1, and then our slope is -1, so from here we're going to go down 1, right 1. And then we're going to take the second equation and we're going to get the y by itself. So I subtracted the 2x over, and next we're going to divide both sides by 2. And then you get the line y equals -x, the y-intercept is 0, and then our slope is -1. So I started here at 0, and then we're going to go down 1, right 1. And you can see that we have parallel lines, so for this system we say no solution. Alright, for this next example it says solve the system of equations by using the substitution method. So I set up a t-chart, and if only one of these equations was already in the form of y equals, we would put that equation here on the left. But since they're both in the form of y equals, I'm just going to arbitrarily use the first equation. And then I'm going to take the second equation and write it over here. So like I said, this equation is already in the form of y equals, and so what we're going to do is we're going to take this equation and substitute it into the other equation. So we're going to substitute this expression in here for y. So now we have an equation with just x, and we're going to solve for x. If you can see, we have a fraction right here. To get rid of the fraction, I'm going to times both sides of the equation by 3. So to do so, on the left, we're going to distribute the 3, and then we're going to do the same on the right. When we distribute the 3 on the right, these 3's are going to cancel, but then you also distribute the 3 to the -8. So I distributed the 3 on the left, and then now when we distribute the 3 to both of these terms, you end up getting 4x and then -24. And at this point, I'm going to subtract this 4x over and then add the 3. So when you subtract 4x over, you get -7x. And when you add the 3 over, you get -21. And so now x is equal to +3. As soon as you solve for one variable, you take it and substitute it into the other equation. So I took the 3 and plugged it in over here for x, and you get -3 minus 1. So y equals -4, and make sure you always take your answer and put it into your coordinate point form x, y. This example says solve the system of equations using the elimination method. This can also be referred to as the addition method or linear combination method. When we do this, we want our x's to be opposite, or we want the y's to be opposite. Just to keep the numbers a little bit smaller, I'm going to multiply the top equation by -2 and the bottom equation by +3. So when we multiply -2 to the top equation, it's going to make a -6y, and when we multiply 3 to the bottom equation, it's going to be a +6y, making the y's opposite. Anytime you do this, just double check that you in fact multiplied every single term by that value. So we get -16x minus 6y equals -26. And then same thing down here, we distribute the 3 to everything. So you get 9x plus 6y equals 33. So now we can add down, and when we do so, we're going to combine like terms. So here you get negative 7x, the y's cancel, and then over here we get positive 7. Divide out the negative 7 and you get x equals negative 1. As soon as you solve for one variable, you're going to plug it back into either equation to then solve for the other variable. So I plugged negative 1 right here in for x, and we get this equation. And then we'll go ahead and solve for y. And again, once you solve for x and y, you're going to rewrite your final answer as a coordinate point. So the solution to the system is negative 1, 7. For this example, we're still going to solve using the elimination method. We need either the x's to be opposite or the y's to be opposite. I'm going to focus here on the x's. We have negative 6x, so that means we want this to be positive 6x, so we're going to multiply the whole top equation by 3. So we multiply the entire top equation by 3, you get 6x minus 3y equals negative 24, and then I just copied over the bottom equation. So when we add down, we have 6x minus 6x, that makes 0. Here, the y's actually also cancel out, so the only thing left on the left side of the equation is going to be 0, and then on the right we have negative 29. And we can all agree that that's not a true statement, and anytime your variables cancel out and you get a statement, you check that statement. If the statement is false, like this one, we say the final answer is no solution. If when the variables cancel out and you get a true statement, then your final answer would be infinitely many solutions. This example says the sum of 3 times the first number and twice a second number is 8. If the second number is subtracted from twice the first number, the result is 3. Find the numbers. I'm going to start with the first equation. Let's think of the first number as x and then the second number as y. It says the sum of, and then 3 times the first number, so we'll start with 3x. And since we have the word sum, I put a plus. And then we're going to do twice the second number, so that's going to be 2y. And the sum is equal to 8. Next it says if the second number is subtracted from twice the first number. So let's start with twice the first number, so that's going to be 2x. And then it says the second number is subtracted from that, so we're going to go minus y, and it's equal to 3. So now we have a system of 2 equations and 2 variables, and we just need to solve it either by substitution method or elimination method. Because we have the y's right here, and this is a positive 2, and this already has a negative, I'm going to use the elimination method and just multiply this bottom equation by 2. So let's go ahead and copy over the first equation as is. And then we'll distribute 2 to every term in the second equation. And now when we add down and combine like terms, we get 7x equals 14. So we end up getting that x is equal to 2. Now we plug this number into either of the original equations. So I just put it in this bottom equation, so 2 times 2 minus y equals 3. And then now we're going to subtract 4 and divide by negative 1. So when we subtract 4, we get negative 1, and then we divide both sides by negative, and we get that y is equal to 1. So our two numbers are going to be 2 and 1. The last concept we're going to cover in this lesson is we're going to solve a system of equations in 3 variables. So we have a little flowchart here on how to solve this. Basically, we have 3 equations, 3 variables, and we're going to use the elimination method. The first step is we're going to choose one variable to eliminate. So we're either going to eliminate the x's, the y's, or the z's. Because these z's are already opposite, let's go ahead and start with eliminating z's. So I'm going to recopy the first equation. And I'm going to recopy the second equation. When you're doing this, use arrows to indicate which equations you're using, just like I'm modeling in the notes. So when we add down, you get 4x plus 6y. The z's cancel, and then it equals 28. At this point, I would circle this equation because now we have an equation with just 2 variables, but before I do so, I want to divide out the 2 just to make the number smaller. So we end up getting 2x plus 3y equals 14. So again, as soon as you eliminate one variable, you're going to circle that equation because we're going to use it in just a second. Now, the key to this problem is we took the top 2 equations and we eliminated z. What we need to do in our next step is we need to choose 2 other equations and also eliminate z. So I want to use the top equation and the bottom one. Still focusing on z, this says 2z and negative z. To make these z's cancel, we're going to need to multiply the top equation by 2. Make sure when you're multiplying the top equation by 2, you get all of the terms, even the term on the right side of the equal sign. Okay, let's double check that I got that. So we have 2x, 8y, minus 2z equals 40. Then we said we were going to use the bottom equation, so I'm going to use an arrow and rewrite that bottom equation. As you're doing these problems, always double check that you got all the pluses and minuses correct, that you wrote down all the numbers right, because it's really easy to lose a sign and that throws your whole problem off. Okay, so now at this point we're going to add down, combining like terms. So we get 4x plus 5y. Again, the z's cancel because we needed the same variable to cancel. And here's our second equation, so I'm going to go ahead and circle it. Okay, so to recap, when you start the problem, you identify one variable to eliminate. So we used the top equation and the middle one, and it made the z's cancel. We circled that equation. Then we took two other equations. We used the top one and the bottom one, multiplying the top by 2, and we eliminated the z's a second time. So the point of this is you now have two equations with the same two variables, and now we can then solve these using the elimination method. So I'm going to recopy them. So this first equation, I just wrote it down, and I'm going to write down the second equation. And again, we're going to solve this using the elimination method. So I'm just going to multiply this top equation by -2 so that these x's will cancel. And again, use arrows so it's easy to follow your work. So we get -4x minus 6y equals -28. And I'm just going to recopy the second equation. And when we add down, the x's cancel. We get -y equals -4. And finally, we solved for our first variable. So we got that y is equal to 4. Next, you're going to take this value, you're going to plug it into one of the circled equations. So I'll just go right here. And we get that x is equal to 1. Now that we have x and we have y, we're going to take these and plug them into any of the original equations. So I'm just going to pick the top one. So for the top equation, I'm going to plug 1 in for x and 4 in for y. And now we can solve for z. And we just found x, y, and z. And what you do is you write your final answer as an ordered triple in the order x, y, and z. And here's our answer. So here's our next example. We're going to eliminate one variable. So I want to work on the x's this time. First step, I'm going to use the top equation and the bottom one, and I'm going to rewrite them again using arrows. So I just recopied the top equation, and now I'm going to recopy the bottom equation. Go ahead and add down. The x's cancel, you get 3y, you get plus 5z equals 4. And then circle that equation. So again, we used the top and the bottom equations, and we eliminated x. So we need to choose two other equations. It just can't be the top and the bottom. And we're going to eliminate the same variables. We have to eliminate x again. So I'm thinking let's use the top and the middle equation because we can just times this by 2. If we multiply the top equation by 2, that'll make -2x, and then we use the middle equation, and that'll give us the positive 2x so that the x's will cancel. Again, when you're multiplying everything by 2, make sure you get that constant as well. So we get -2x, positive 2y, plus 4z equals 4. And then rewrite that middle equation. And again, use arrows so that when whoever's grading your paper, they can follow your work. So the x's cancel, then you get 3y, and then plus 3z, and we get equals 0. I was about to divide the whole thing by 3, but then I glanced over here and saw that this has a 3y, so that's going to be helpful to eliminate the y's. So let's go ahead and recopy these two equations over here so we can solve them by elimination. All right, and I'm going to multiply this top equation by -1, and then use my arrows, drop down the second equation. And now the y's are going to cancel. We get -2z equals -4. So z equals 2. As soon as you get your first value, you take it and plug it into one of the circled equations. So I'm just going to substitute it in right here. So we get 3y plus 5 times 2 equals 4. And now we can solve for y. So go ahead and subtract 10 and divide out the 3. And you end up getting that y is equal to -2. Once you have two variables, so y is -2, z is 2, you take them and plug them back into any of the original equations. So I'm just going to plug them into the bottom equation. So we get x plus 2 times -2 plus 3 times +2 equals 2. So again, you can see I plugged in -2 here for y and then +2 right here for z. And let's go ahead and finish and solve for x. So you combine like terms and you get x plus 2 equals 2, so then x is equal to 0. And now that we have all three variables, we're going to write our answer as an ordered triple in the form x, y, then z. So here's our final answer, 0, -2, and 2. Thanks for watching, guys, and don't forget, like this video and subscribe to Math with Yosh. Have a great day.